Hello again, gang. Mr. Cruze here with another Math 10 lesson for you. This time, we're going to be talking some linear inequalities. Yesterday in class, we talked about graphing equations, linear equations, in the form y equals mx plus b. We discovered that the y-intercept was b, and then you moved your slope, which was m. We're going to be talking linear inequalities today, which more or less follow similar rules. A couple things, though. Instead of having equal signs between them, now we will have things like greater than symbols or less than symbols, okay? The difference between these two is with your linear equation, you just had a solid line that was your answer. Every point on that line was a solution to your equation. If I plugged in the x and y ordered pairs, it would make the equation true. And inequality is a little different. Sometimes you have solutions that are on the line, sometimes you don't. And then you also have some solutions that are below the line or above the line. Okay, so there's a lot more solutions here than there were before. A couple of rules that we need to remember. First off, if we have greater than or less than, we're going to draw a dotted line or a dashed line. It will not be solid, dotted. Okay, if we have greater than or equal to or less than or equal to, it still has the equal to part, right? Which means it's just going to be a solid line, okay? So if it doesn't have the equals, it's dotted, which means any solutions on the line are not included, whereas solid means the solutions on the line are included as well. And then we'll also have to remember a couple other rules. For instance, if we divide by a negative, we have to flip the inequality, and there will be some shading that we get to do, all right? You'll see. So here we have number one, y is greater than negative 3x plus 2. Notice it's in that form, mx plus b. So I'm going to graph it very similarly to what we did yesterday. I'm going to start at the y-intercept on the y-axis, and I'm going to move my slope. My slope is negative 3 over 1, so I'm going to go down 3, right 1, and put a dot. Now, here's the difference. Yesterday I just would have connected those, and boom, my line would have been done. But today I'm looking at this, and I see that its y is greater than that line. So greater than doesn't have the equal part, so I'm just going to do dotted lines, okay? I'm just going to draw the best dotted line that I can. It doesn't have to be perfect. Nobody's expecting perfection here, all right? If you want to be more precise, you could get more dots and go that way if you want, but it's not that big of a deal, all right? The other component to this is the shading. Okay, where is my solution exactly? If it's not on the line, it has to be elsewhere. And that's where the greater than comes in, all right? We're going to shade everything that is greater than this line. And when you think greater than, you're usually going to think up. So we're going to shade everything above this line. Okay, you will notice that splits the entire coordinate plane into two halves. All right, there's the half over here that has values that will not work for this inequality. For instance, you notice 0, 0 doesn't work. 0 is not greater than 0 plus 2, right? 0 is not greater than 2, that's why it's not shaded. Whereas you have the half plane over here that does consist of solutions. If I tried any of these points over here, they would work in this inequality. Moral of the story, if it's greater than, shade above, and also notice that the line is dotted. Other than that, it's exactly the same as what we did yesterday. All right, let's take a look at number 2. 3x minus 4y is greater than or equal to 12. Let's go ahead and solve for y. So I subtract 3x from both sides. I get negative 4y is greater than or equal to negative 3x plus 12. And then I divide everything by negative 4. Now, little red flags should be going off in your head because I just divided by a negative. That means I have to flip my inequality. We didn't have to pay attention to that with equations because flipping an equal sign doesn't do a whole lot. But with inequalities, you have to switch the direction. So now my equation is y is less than or equal to 3/4 x minus 3. You notice the negatives canceled there. All right, now I graph it. Minus 3, I go to negative 3 on the y-axis. I move my slope up 3, right 4, put a dot. Now, here's the deal. This one has an equal sign, so I'm going to draw a solid line, just like we did yesterday. However, it is still an inequality, and I still have to pay attention to the fact that it's less than. Okay, less than looks like an L. So that means I'm going to go below the line. So I'm going to shade all of this, okay? You're more than welcome to use different colors if you'd like. You can just shade with your pencil. You don't have to make it dark or anything, just as long as I can tell what is shaded specifically. All right? And then we also talk a little bit about these sorts of things. You'll remember yesterday I said y equals a number is a horizontal line. Okay, and you'll remember that if I said x equals a number, it's a vertical line. Same rules apply for the inequalities, except now I have to pay attention to, is it dotted or solid, and where do I shade? So y is less than 2, okay? So I know it's going to be at 2, and I know it's going to be a horizontal. Because of my inequality doesn't have the equal to, I'm going to have a dotted horizontal line at 2, okay? Remember, those points do not count as solutions. Okay, if I pick the ordered pair 1, 2, if I plug in 1 for x, which there is no x, so I can't even plug it in, and then 2 for y, 2 is not less than 2. So the points on the line do not work. That's why it's dotted. However, the points in the region that I shade will work. So you notice it's less than, so I'm going to shade below the line. Anything that is below this line will be shaded. So that's all of this down here. Okay? And you notice you can try a point like 0, 0. Plug in 0 for y, 0 is less than 2. That works. All of these points down here have y values that are less than 2. All right, how about x is greater than or equal to negative 3? Well, vertical line at negative 3. I know by looking at it, it's equal, so it's going to be a solid line. And then now I just have to figure out which way I shade. Well, it's greater than. So normally I would say above the line. The problem is, with a vertical line, there's not really an above or a below, but you can kind of reason that the arrow is going to point the way. Greater than is this way. Okay, we're going to shade this direction. We're going to shade all the way over here. All right, those are all the points that have x values greater than negative 3. Okay, so the shaded regions contain my solutions. That will be important for problem 5. Circle all the solutions to the graphed linear inequality. This is similar to something you might see on a standardized test where they want you to circle all of the possible answers. There may not just be one answer here, okay? So all the solutions. So to be a solution, it must be in the shaded region, okay? To be a solution, it must be a shaded region. Notice I don't even have the inequality. I do know that it's greater than, and I know it's not greater than or equal to because it's a dotted line. So I know whatever this is, it's greater than. So it's y is greater than something, and I could figure it out, but I don't think that's terribly important. So anyway, let's see if the point 3, 2 is in the solution. So here is the point 3, 2. It's right there. Is it in the shaded region? The answer is yes, it's in the shaded region, so that is a solution. Whatever my inequality is, that ordered pair would satisfy the inequality. How about 0, 2? Well, 0, 2 is up here. It's right there. It's actually on the line, and this is a little bit of a trick question. Is it in the shaded region? Now, being on the line sometimes is okay. It's okay in the case where the line is solid. In the case where the line is dotted, that solution does not work. So that is not a solution. It's technically not shaded, if you want to think about shading the dotted line. How about negative 2, 3? Well, negative 2, 3 is over here, very clearly, firmly not in the blue shaded region. Okay? And my last point that I need to try is 2, 0. 2, 0 is over here, and that is solidly in the blue shaded region. So there are 2 points listed here. There are others. For instance, you could pick like the point 1, 5. That's a point that would satisfy 0, 6. You know, there's all sorts of points. I mean, really, there's a whole half plane of points here that you could choose from. But anyway, those are the only 2 that work for this particular question. All right, I hope that helps. Graph them just like normal lines. Pay attention to when it's solid versus when it's dotted. Okay, pay attention to, does it have the little equal bar under the inequality symbol? Pay attention to horizontal versus vertical, and pay attention to which direction you're shading. Don't forget, when you divide by a negative, flip that inequality. All right? If you have any questions, you're more than welcome to message me on Canvas. You can email me, and I will try and reply as quickly as I can. Your job now is to work on the 10 questions on the back of these notes. All right? I hope you have a wonderful weekend, and I will see you Monday.